I'm gonna go over my assignment 3 of data science. So these are some instruction that we have to keep in mind. Just not wasting time here because I have already read that a couple of times. So from party, so thanks to Python for we got a lot of libraries. So we are just importing the numpy, GPL images. We are going over the such. It's all about the image. So we are using the SKP Max as SK image and importing data as well. Color for the RGB gray. We are as well as importing the Matplotlib library and importing requests here. So first of all, we're just getting the image from the URL this professor provided here, and we just store it into the response. We are just trying to get those response to the print console. So as you can see, there's lots of axis and 0 and 1, lots of character here. It's not human readable, I would say. Over here we are just converting those bytes to an actual input image array. That's so byte IO is buffer the image into the RAM, and we are using over here the image open. That's gonna open the buffer image. So whatever is bio is buffering, it's gonna open that image and converting into the number pi. So num array, so np array, array is transferring the array into 3D contains value like some RGB, right? So say from 0 to 255, to just converting those two and just storing the input image array. We'll see our image here. As you can see, it's I have already run all the commands, so I didn't I don't want to waste the time on running because it took so long to run all the epochs. I'll show later when it comes. So basically I was saying it's plotting the image from the array. So we just I'm sure just using the library to show the image. It's a nice Lamborghini, I love it. Sure. And let's go now there. Yeah, printing the array shape. We just printing the size of array. You'll see here is 114 to 359 by 3, and then compare those value of color channel 0 and 1. So you can see as here and array equal, you just checking this channel 0 1 and 1 2, so you can see those are not equal, and it's returning just false for both. So say the color channel 0 in the input array will have print it. So as you can see here, we change it the color there and it become the yellow lambo from the red one. We'll do modifying the later steps as well. So this is the array image. So 255 is, I would say, the highest of the density layer. Okay, there's lots of data here. So conversion with 2D, so how that works, we have seen that video as well, so not going there. So over here they created paired array by adding like 2 rows, 2 column, one for each beginning and one for the end, and they just filled that with zeros with the same type of input errors. So compare both arrays. So we are comparing the original shape array, input image array dot shape, and the padded array, the one we just created now. So we just comparing those. So this is that size 142, and applying the kernel to the array value. So we are over here doing what, applying those kernel to the array values. So one is the padded array dot shape, and we are just temporary. I know it's a temporary, the one was the original. So we're just applying a ranging from the minus to temp array, just adding this value output, and you can see here just change that color and pass the gray as an color, you can say. Yeah, for that PLT library, for that image. So it's a white lambo or gray lambo, you can see here. Okay, so define a function that squares out the value between 0 to 255 range. So what will this function do is just resulting the array and value can be negative or greater than 255. So just function here. Over here, which is predefined or given by the purpose to define a function to apply convert 2D array to an image. So convert 2D kernel. So just some arguments are there. Input just array one kernel, and we just passing the was pixel to the true. So this is default argument. So what we're doing is just going over that kernel width and height, and just transforming those errors, and you will see in the next steps. So line detect with image evolution, you can easily detect the line. Here are the four convention to detect horizontal, vertical, and line at the 45-degree. Okay, so this is the image kernel passing 222. That's like the shape of this one, applying those kernel to the image. So what we're doing, the one we declared over here, the what is that, yeah, conversion 2D kernel, convert 2D kernel. Okay, yeah, so we're just calling that, passing those image kernel equal to horizontal kernel, and just plotting that image, and you can see, you can barely see, I mean, it's a light one, and we'll see that in the next step. So based on the kernel representation of the image, the kernel detects 45-degree line using convention, apply the car image and plot the result. Okay, so this is the like 90-degree like this. Okay, let me just do it again. Yeah, this is 90 degrees, 45 degrees like this in the middle, right? So as you can see with that, so this is our actually it should be the 90-degree, but we're using 45, so this is the 45-degree angle. So we just did the transfer 45-degree conversion just to, and just passing those kernel as we define here, my kernel, and the input image. Just you can see there's a difference. You know, this is the light one, this is the, you can see properly the borders and as well. So based on the kernel temperature of both image, create a kernel to 135. Okay, so doing the same thing, creating my another kernel. So that is this is suppose the 90, so you can see this is 180 and this would be 0 right over here. So this is 135 here, so you can see the 222 there. Yeah, so we're just doing the same thing over here, just passing the image kernel, my kernel to the one we declare here, and you can see there is a difference in the image both. You can easily see the difference in three of them actually. So there are some question here, question to apply the following kernel to image and plot the output. Okay, so what we are doing here is transport JS kernel, just calling that function with this edge kernel, the one is already declared predefined. So as you can see, it's really light. I mean, there's so only few, you can barely see the shape of the library and hard to recognize. There is one more, so it just one makes the image sharper because we are just passing -4. There is so makes it a little cool, and you can say sharp one. Yeah, we just increasing the value to 8 plus 8, and as you can see, it's a complete Lambo. You can recognize it from a way better than that, the way better than the way 2 before. So part 2, I mean part B. So we are again some importing libraries like Keras. Yeah, I just fixed this part because the Keras storage details wasn't working on my side. It happened in the last level also. I don't know, maybe something on my side. So I just tried to fix that TensorFlow.Keras, so it was okay after that. And then we're reading some data, loading a lot of data here. So what are we doing is here, train image, train labels, test image, test labels, and the one we is a CFA 10. So loading this data, lots of data. I already load that out, so not wasting time here. Okay, so one hot encode target values and convert from integer to float. So as you can see, just converting those to float, and then yeah, so we are just normalizing RAM from 0 and 1. It will be between 0 to 1. Okay, so building the neural network. So as this is, we are model, I mean creating a model, and just with layers like one max pooling, flatten, dance, 2 layers here with the activation relu and the sort max. So over here, compile time, compiling the optimizer, loss category cursor, make accuracy. So we are just displaying the summary whatever is written here. It just you can see in the good way, I mean in good way. Yeah, so yeah, I mean 5 layers, convert the max pooling art, flatten, dance, and dance one, and this parameters and this shape of this. So just passing 10 of the dance as you see here, and the 128 for that. Okay, so custom class, create a custom callback will be called during the training. So this is pretty fine as well from the side. So as you can see here, it's a match exclamation help epoch and the log. So epoch just dividing into the mod 5 and just printing the accuracy for the accuracy and the value validation accuracy. Okay, so instantiate the custom callback here. So we're just doing lots of work here, like training the network. That's the hardest and time consuming part. So train the network with the labels. So we're just doing epoch of 5, bedside to 56, going over the lots of time. So as you can see here, the validation accuracy reaches the 41 at the initial, and the validation is 45. And the next epoch 5, and the accuracy was 64, 42. And this is the one where it was the peak at the peak, 64%. Then after, you can see as it's dropping, it went up again and it dropped at the end. So even though the validation was going so yeah, I mean the accuracy was going up, the validation data was not the so you can see where he results here. So we're just printing the stuff here. So initially it start with good up to like 10 epoch, and then having the good job, even though the training accuracy was kept going up, it reached almost 95, I think 92 95%, but validations just stop after the 10 epoch. I'm gonna do some question and answer here. So did the network present a sign of overfitting? Yes, it definitely overfitting, because we are doing too much epoch, like 50, so definitely it's gonna overfit. Yeah, there was some overfitting, like after that, how the accuracy will dance despite the training accuracy still continues to improve. Okay, so next one is write down how many layers. As I already show you here, where is it, yeah, there are 5 layers constantly: max pooling, pleasant, and to dance. Yeah, and so to dance one is by Brello and Max of Max. Next one, briefly explain what is the purpose of each of those layers. Okay, so I'm gonna just go over those layers and I'm just gonna explain in simple what's conversion layer that takes the image and look at the small like pieces, you can say. So we have then max pooling layer that take the largest value in each of those chunks and conversion network data, and then shrinking the image while maintaining the strength of the picture. And we have a flatten layer that converts the data to 1D, so that a network can easily learn from that 1D, so one dimensional data. We have a dense layer with the rel activation function to zero the negative value, and the last one we have sort max activation with which is dense layer as well. Probably output the function with the 10 output label for the data set. It one yeah, so add one more conditional layers to the, so we are just adding one more and run it again. So it's gonna just changes the value, and running those stuff again. Took a while for me to go over all the stuff, and as you can see here, we reached almost 70. Yeah, and the 10 epoch, yeah, 10, you can say, or 10 or 20, yeah, 10 15 I would say in the middle. And then going down again, like you can see here, 42 to 69, and yeah, 50 67 70 70 70 70 69, and then again dropping. So was doing good in the middle part. Anyways, so what we're doing is compare the result, describe what the difference between them. So in the new model with the two constant, they are able to test the better accuracy. As you can see, it's almost 70 for all the 10, then went down for a little bit, like 16 8 or 9 at the last couple of epochs. So yeah, again you were, and then you can see overfitting starts at the 10 after that, and it's quicker and more accurately. Add a dropout layer to your model, run it, and compare the result with the previous one. Okay, so as you can see, I have at the dropout like 750, that's a 50%, and just doing those again, and there are really good number. As you can see, it just quickly went to the boom 65 or 70, 65, but with the training it did a good job with validation accuracy. was a good one. I mean, yeah, from the starting, it's a good one. But when you can see on it was keep going up. Good job at that. Explain your what's the purpose of dropout and how it works. So dropout is basically like let's to randomly zero out. So some of the output feature during the training, yeah. So basically keep the neural network fresh every time a dropout occur and enhancing the network unique solving. So it makes it adaptive and on unseen data. So like the data that is new to that neural network, right? So it makes it yeah, makes it fresh every time. So like you're doing some exercise or stuff like every day regularly, and then you that must be your that mean you must be fit. So you are adaptive to the new games and training you get every time, so you don't have to worry about that. But the one person who is lazy and like me not doing the exercise regularly, so they have to they'll face a problem when they go for the some training or the exercises initially. So this is basically in the simple words I was saying the dropout layer. That's how it works and keep the neural network fair, and it's making it better for unseen data. So make any other modification happen to improve the model accuracy and compare the final result with the previous one. Okay, so we did some modification connection layer. You see flatten here the same thing, and just learning for the last time. As you can see, it was way better than the previous one. As you can see from the starting point, it just was doing great shape other than validation data, and then maintain that accuracy till the last epoch, and it is one of the best. And you can say it was improving. You can see here the last from the first 10, I'm just showing you 10 to, and the last 150 was the 77, so it was improving at the last epoch. So that was the best one. And yeah, that's it. If you have any question, comment out. Thank you so much. Have a good day.